Guys, I'm going to be helping you to get through the guided practice for the trigonometric ratios problems or the trigonometry problems. Let's go ahead and start with our problem. Notice here that I got rid of in radical form. Instead, we're going to round to the nearest hundredths place. Just a quick review of the hundredths place. That's when you have a number that is two places after the decimal, and you use the third number to decide if this one is going to stay the same or go up. Whoa. Okay, that really went up. Okay, so we're now going to move on to the actual problem. It says rounded to the nearest hundredths place. What is the perimeter of this trapezoid? So when you're taking your test on the computer, you will be able to do highlighting. And the things that I would highlight here are things like to the nearest hundredths place, because it tells you which form to put your answer in. And of course, the question, which is, what is the perimeter? I would specifically highlight just perimeter if I had one color, but we have two colors here, so I'm going to do it this way, of the trapezoid. Okay, so I'm going to go ahead and start by talking about perimeter. Perimeter would be the distance around the figure. So let's go ahead and indicate what that is. The distance, they can give you problems like this, or they can say, hey, Sally wants to walk around the outside of her apartment complex. How far would she walk? And of course, well, hopefully it wouldn't be inches because she wouldn't have done much. But that's another context that they could give you this problem in. Or let's say there's a yard and they want to know how much fencing they need to go around the irregular yard, and you would use perimeter for that as well. Okay, so we're going to do each of these problems, guided practice problems, using a process chart like you've used in class. The first step here is, what are we trying to accomplish? So clearly we're trying to find the perimeter. And in addition to that, as a visual aid, we've highlighted the perimeter so that you can see what is valuable and what is not valuable. And what that means is finding these inside segments may be valuable in helping us to find one of the outside ones, but just knowing them for the sake of knowing them is not helpful. We want to know the highlighted area, or the highlighted sections, which would constitute the perimeter. Okay, step two. What can the figure tell me? Okay, so here we're going to label the figure according to the properties of polygons. Basically, at this point, we have 8 here. What do we know about? Let me go ahead and grab me a marker here. What do we know about the figures that we have here? We know that we have a right triangle here, we have a rectangle here, and we have another right triangle here. So far, I'm seeing opposite sides parallel and congruent in a parallelogram. Rectangle is a specialized parallelogram. I know it's a rectangle because it has these two right here, and yeah, okay. And so that would make this 8 inches. Okay, is there any other labeling we can do? Let's see, we have this here, this here. Okay, as of right now, there is no other labeling that we can do. Just for your information, there is something we can do. And whenever you see a 45-degree angle within a right triangle, the other leg is the same measurement as the other one. So this is actually 6 as well. But we're going to go ahead and solve for it in the problem. But if you recognize that shortcut, it's a 45, 45, 90, because if you have a 90-degree angle and a 45-degree angle, all you have left over, according to the triangle sum theorem, is 45 right here. So that would make these two, that would make this an isosceles triangle basically, and this would have to be 6, and across from the other base angle, this would be 6 as well. So 6 and okay, so moving forward, step 3, how many figures are there and what types? We discussed that already. There are 2 right triangles, not congruent, and there's also a rectangle. Okay, which figure should I start with? So you're going to start working on the figure that gives you the most useful information. So I'm looking over here, 30, a 60, I mean a 30 and 90. I could figure out that this was 60, but that still wouldn't help me with the perimeter because that's an angle, and I want to know the length of these outside segments. Okay, I'm looking at the rectangle here. The sides are not revealed as yet, if you don't know about the 45, 45, 90. So I'm going to go ahead and go right here with this right triangle because I have an angle and a side, and it's a 90-degree angle in it, so that means it's a right triangle, so that means that I can use trigonometry to go ahead and solve for another missing side. So what I want is this side because it's on the perimeter. So I'm going to go ahead and put my X here. This is what I am looking for. Okay, now I'm going to go through the trigonometry process. On the other problems that we're going to do, it'll be more explicit with the process chart, but I'm just going to go through the process here. Okay, so the first thing I'm going to do is I'm going to circle my focus angle, and I'm going to label the opposite, hypotenuse, and adjacent. So obviously the hypotenuse is across from the right angle and the right triangle. The opposite is opposite of the angle, and the adjacent will be what's left over or what's right next to the focus angle. Okay, so after I do that, I'm going to go ahead and choose from SO, CA, and TOA the right trigonometric ratio. So the way that I choose that, and let me actually write SOHCAHTOA here. So and, or I'll say CA or TOA. I choose the trigonometric ratio based upon what I have and what I need. So I'm going to go ahead and go the extra step, and I'm going to box around what I have. In this triangle, I have A. I don't have any other of the sides. And what I need is this segment. I may need this inside segment later to help me find something else on the outside, but what I really need is this right here because I'm trying to find the perimeter. So I'm going to circle what I want, what I need. Okay, so based upon that, I'm going to I'm going to choose the trigonometric ratio that has A and H or A in it, and that would be Ka, or otherwise known as cosine. Okay, so cosine of my focus angle, 45 degrees, would be equal to A over H. A in this case is 6. H is what I'm trying to find out. So I'm going to go ahead and put that there. I could put an H or an X there. It wouldn't matter. Now I'm going to go ahead and go to the next step, which is I'm going to, after I fill this in, I'm going to turn it into a proportion by putting the trigonometric part of it, the cosine 45 over 1. Now I'm going to cross multiply. So let me go ahead and go over here. Okay, so 6 times 1 is just good old-fashioned 6. And cosine of 45 degrees. That was an awesome degree symbol. Okay, times H. So I'm going to put parentheses here. And then after that, I'm going to isolate H because that's what I'm looking for. So I'm going to go ahead and do the opposite of what's happening between them. They're being multiplied. So I'm going to divide by the cosine of 45 degrees on both sides. And I like to do all of this manipulation with the problem before I turn the cosine, tan, or sine of the angle into a decimal because it's kind of annoying to write that decimal over and over and over again. Okay, so this cancels and you end up with an H equal to, and then 6 divided by whatever the cosine of 45 is. So I'm going to go ahead and grab a calculator. Uh-oh, I might be in trouble. Let me see. Nope, I'm not. Scientific calculator right here. Okay, so I'm going to go ahead and grab a calculator. Remember, I'm dividing 6 by, so I'm going to say 6 divided by, I'm going to put some parentheses here, cosine of 45. This is a traditional scientific calculator, so I'm going to go ahead and put the 45 in first. I'm going to take the cosine of it, and then I'm going to close those parentheses and hit equal. Okay, in which case I will end up with 8.49, we'll say. 49. Okay. All right. So taking a look at that, I had 8.48 at a 5 after the 8. I want 2 places after the decimal. So the 5, because it's larger than 4, is going to make the 8 go up. That's why it became 8.49. So let me go ahead and minimize that calculator. Okay. So this represents H, or this measurement right here. Let me put that in red. So 8.49 is what we're working with for this side. And we are not done. We're not done because we have to find all of the sides. Now, here we know 6, we know 8, we now know this. Let's see how we can move through the rest of the figure. Okay, so looking at this right triangle, I have 2 out of 3 sides. So instead of using cosine, I can use Pythagorean theorem to find the measurement of this third side. Now, this third side is not on the perimeter, but if I figure this side out, it'll tell me what this side is, and that'll give me more information on this triangle that has the missing pieces, because I have the pieces for everything else. See? I need these two, but I need some more information on this triangle, so I'm going to use this parallel and congruent side in the parallelogram or the rectangle to help me get more information about this triangle. Okay, so now let me go ahead and I'm going to go ahead and draw. Actually, no, I'll leave it like that. Okay, let me move this up, give myself some space, put me a line in there. Awesome. Okay, so back to my marker. Okay, so now we're going to go ahead and move on to the next part, which is going to be Pythagorean theorem. A squared plus b squared equals c squared. Now the tricky thing about this is you have to make sure you get the c in the c squared spot. So here, a lot of people will be tempted to say, hey, I know these two sides, so I'm going to put this as a and this is b. That will be incorrect because this is actually the hypotenuse. Remember, the hypotenuse is always c in a right triangle. So I'm going to go ahead and put my 8.49 squared, and then the other side that we know can be a or b. I'll go ahead and make it a. So 6 squared plus b squared, which is the part that we don't know. We're trying to find the side right here so we can find out what this is. Okay, so moving forward. Okay, using that handy dandy calculator again, actually we don't need it here. This is 36 plus b squared and 8.49 squared. I still have the same thing in here, so I'm just going to go ahead and square it if I can. Yeah, it's right here. Okay, and you have this function on your simplified calculator as well, and also on your Texas Instrument. So let me go ahead and square it, and you end up with 72. Nice clean number. Okay, so 72. Okay, now I'm going to go ahead and subtract 36 from both sides. I'm solving a simple algebraic equation now. Let me draw my line down. Respect my left and right hand side of my equation. Okay, so b squared is equal to 36. And it just so happens that if you take the square root of both sides, which you would need to do, you're going to end up with b being equal to 6. So now we have another measurement. Remember in the beginning when I said if you have a, okay, so yes, if you see a 45-degree angle in a right triangle, that's an indication that it's actually an isosceles right triangle. Therefore, the two legs are congruent. So you could have also passed this step if you remember that. Okay, at any rate, so we know that if this is 6, that means that this is also going to be 6 inches. And we have enough information now to find some of the sides or find B sides on this right triangle. So I'm going to go ahead and draw a line down here. And we're going to go ahead and get started on that. Let's see, marker, purple. Okay, okay. So now we're going to go ahead and take a look at the information we have here. Do we have 2 out of 3 sides so that we can do Pythagorean theorem? No, we only have one side, but we have one side and an angle in a right triangle. That means we can use trigonometry. So going ahead and going from the beginning, I'm going to put a circle around the focus angle. I'm going to label opposite, hypotenuse, and adjacent. And then I'm going to go ahead and choose the right trigonometric ratio based upon what I have and what I need. Let me go ahead and put a box around what I have. I have this one, this side, which is O, by the way. And what I need is, I actually need both of these. So you could choose either one. I'm going to go ahead and go with the hypotenuse to start. So I'm circling what I need. So what I have and what I need, that's O and H. O and H is so I'm going to say sine of my focus angle. Let me try that again. Sorry about that. Okay. So sine of my focus angle, which happens to be 30 in this case, is equal to O over H. O is 6 over H, which is the hypotenuse, which we don't know. Okay, and here we go. We're going to turn it into a proportion. see here. So we're going to turn it into a proportion, then we're going to cross multiply. So cross multiplying. I'm having a hard time with the mouse. Sorry about that. Okay, so this is going to end up being sine 30 degrees, sine of 30 degrees times h. I'm going to put the sine of 30 degrees in parentheses, equal to 6 times 1 is 6. Notice that I set this up slightly differently. It doesn't matter. Okay, if you put this product first or this product first. Here I put this product first. Okay. Okay, guys, so we're going to go ahead now and find the sine of 30 using our calculator. So, oh, wait, I jumped ahead here. Sorry about that. Okay, so we're going to divide by the sine of 30 on both sides. Sorry, guys, I had an interruption. Okay, we're doing the inverse of multiplying by 30 by dividing by 30, and we're going to end up with h equal to, and then we're going to use our calculator to do this. So I'm going to do 6 divided by, in parentheses, sine of 30. So I'm going to put the 30 in first. Sine, close the parentheses, equal to, very neat, 12. So h is equal to 12. So let's go ahead and put that on the figure. Let me go ahead and grab a red marker again. So this is going to be 12. We're almost there, guys. So now we have a choice. We can actually use Pythagorean theorem because we have two sides on a right triangle. We can use Pythagorean theorem to find the third side, or we can use trigonometry again, and this time focus on what we have, which could be H or O, and what we need, which is A. So we would have a choice on which trigonometric ratio we would use. But I'm going to go ahead and just use good old-fashioned Pythagorean theorem. We have 12 as the hypotenuse and 6 as one of the legs. So let me go ahead and move this down so we can get that done. I'm going to draw it in this time. Okay, so we have A squared plus b squared equals c squared. And c again was 12. The tricky part is making sure you get c where it needs to go. 6 can be a or b. And now we're going to go ahead and simplify. Let me draw my line down, respect my equation. 6 squared is 36 plus b squared equal to 144. When I subtract 36 on both sides, I end up with b squared equal to, I believe it's going to be 108. Let me go ahead and move this down. Okay, take the square root on both sides because the inverse to squaring is square rooting, but I have to do it on both sides to keep it balanced. B is going to come out free and equal to, let's find out right now. So I'm going to do 108 and then hit the square root button. Do, 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 do. Hey guys, I had to jump to the other calculator to do it 108 and then take the square root. It doesn't look like this on your calculator. On your calculator, it'll look like this. But let's go ahead and hit the square root button. And we end up with 10.392. I'm going to write that whole thing out just to demonstrate rounding to, was it, let me go back, 392. So let me go ahead and get that in right. 0.392. Okay, because we're rounding to the nearest tenths place, I'm going to go ahead and round here. I mean hundredths place, I should say. I'm going to use this to let me know if I leave it the same or go down. Because it's less than 5, it's going to stay the same. So 10.39. Okay, so B is equal to 10.39. Let me go ahead and put that on here, which actually happens to be, yeah, this unknown. So 10.39. Now at this point, are we done? We are not done because we have to go ahead and find the sum of all the sides. So let me go ahead and do that now. So it's going to be right here, 12 plus 8.49 plus 8 plus 8 again plus 10.39 equals 46.88. and that's our perimeter.